You managed to make that? Oops. That's not good. There they are. Okay, there's all the outcomes. Those are all the totals. So you can count, right? If you say, what's the chance of getting a total of 10? Okay, this probability over here. Where is that on here? It's that one, that one, that one. If you can construct the sample space and count outcomes, that's the simplest way to work out probability, right? So this is out of 16 total outcomes, there are 3 of them that you're looking for, right? Well, it says a win a total of 10, right? A total of 10. I guess the wording a total of 10. If it just says you win $10, then it's the ambiguous one, right? You're right. They could say you win exactly $10. Exactly. Now the same number. Okay, again, just counting outcomes. We're not doing anything other than just writing out the sample space somehow and counting outcomes. The same number is this 0, 0, that one, or that one. Now I colored that one, it looks green, but it's those 4, right? There's 4 of them. There are 4 out of 16. If you want to, you can reduce this. But again, this has the advantage that it shows you all the outcomes. There's 16 outcomes and 4 of them are what you want, right? Incidentally, if you look at the way I just did that, this is, we're going to look at things in the future here that involve the word or. I think if I had asked you this, what's the chance of getting, let's do this over here. Probability of getting a $10 or the same number comes up. Chance of getting $10 or the same number comes up. You might say that there's 3 ways I can get $10, right? 3 out of 16. And what was the chance of getting the same number? 4. So what would you think that, since you're asking for or, what do you think the probability would be? What would your guess be with those 2 numbers? 7, right? Can you look at the picture and see that it's not 7 though? It's 6. Why is it 6? One of them gets counted twice. This is what we're doing in the next tutorial, but I want you to think about it while we have this written out here. If there's an overlap, when we did things in combinatorics, we never had overlap between the things we were counting, and so you could just add the 2 numbers. Here, sometimes there's going to be overlap. When there is an overlap, you got to deal with that. If I take the 3 and the 4 and add them together, I've counted that overlap twice. So the shortcut next time is going to be, if I subtract the overlap once, I get the right answer. Okay? But that's what's going to happen in the next thing, in the next tutorial, right? That's foreshadowing. Not really foreshadowing because I told you exactly what it is, but the last thing here has you think about if you do not replace it. Without replacement means after you make your first choice. So I had to change it from a spinner to choosing things out of a hat or a pot or whatever this is here. When 2 bills are randomly selected from this pot, without replacement means once you choose the first one, you don't put it back. You can still make this with a table, all right? Maybe you can just copy and paste your table. I won't make you feel bad by copying and pasting. I'll redo it. 0, 5, 10, 20. 0, 5, 10, 20. Okay, so here's your table. Except this time, what things are all of those? Are there 16 outcomes again this time? How many outcomes are there? On the first choice, how many things could you get on the first thing? 4. On your second choice, how many can you get? 3. There's only 12 outcomes this time. Which ones are not possible here? Because it should match our sample space. 0, 0. Right? Those 4 we counted in the previous question can't happen. There's only 12 outcomes, the remaining ones there. Those ones can't happen. You can cross them off. If you fill out the rest, then it's the numbers the way it was before. That's a 5, 10, 20. 5, 10, 20. That's 15. That's 15. That's 25. That's 25. This is 30. 30. You cannot win 40. You can't win 0. You can't win 40. If you want the chance, you win a total of $10. What you need to do here, if you do this, chance of $10 here, which of these two numbers should you look at first? The numerator or the denominator? Should you look at the total or the favorable first? Which should you look at first? Which should you count first if you're counting? Well, it's fair. You have to, if you're counting the favorable out of the total, right? If you just say, well, favorable is I could win $10. So let's see, I could get 10 and 0, 5 and 5, 0 and 10. So I'm going to put a 3 here. It's not 3, right? Because all of those can't happen. Which one of those can't happen? This one. It's better if you count the total first, because then you know which things aren't there, right? There's this condition that you can't have the same number, right? Because you're not allowed to replace it. There's only 12 things here. It's 2 out of those 12. I think it's always better you count the total first. You at least look at the total, write out the whole sample space, or otherwise think about what the total is. I think a tree diagram for this gets tedious. I did put it here, but maybe you can see why it's going to get to be a mess, right? If you did 4 branches here, and then each of those has, well, only 3 this time, right? Because there's only 12. The previous one would have 4 and 4, the 16. The tree diagram really helps you see how many outcomes there are, multiplication-wise. This is 2 out of 12. Or 1 out of 6. If you compare that to when you could, the thing up above, in the previous one it was 3 out of 16 winning $10. In this game it's 2 out of 12. Which one has the better chance of winning $10? The first one, right? 3 out of 16. So what is 3 out of 16? Is it? What's 3 out of 16? What percentage is it? Because you can express these as percentages. 1 out of 6 is like 16.7% roughly. What's 3 out of 16? It's pretty close, actually. What is it? Somebody going to divide this for me? 1875? 18.8 then? So in the first game, it's a little bit higher chance you're going to get $10, right? If you were a person who is setting up this game, if this game was free to play, is this a good game for the person running it? Are they going to make money at it? They're not going to make money if they don't charge anything. If they charge you $1,000 to play, is anyone going to play? No. They would have to understand probability well enough to make the price low enough that you think you might have a good chance of coming out ahead, but not actually high enough that they're going to lose money overall. What you'd actually have to do is figure out the average amount of money someone wins. If you wanted to do this really, you could take all 16 outcomes, like you could add up all those possible outcomes, figure out what the average return would be, the average amount of money someone wins, and charge more than that. If you worked out the average, I don't know, it's somewhere $15 to $20, so you'd have to charge somewhere in there. If you worked out the average, again, you could add it all up. It probably is somewhere in that neighborhood. But so if you charge someone $20, you might come out ahead, right, eventually. Do you think a lot of people would play? That wouldn't be do you think that would be a good game to charge? Someone's going to say, I'm not going to pay $20 if all I can win is $40. The way you get people to play is you make this prize like $1,000, but you have a whole bunch of times when you win basically nothing here. Because then those people think, oh, I might win that 1,000, right? Even though there's 999 times they win nothing, right? Lotto 649, you think, oh, I might win. Most of the time, like, one time you win $1 million, 13,900,000 and whatever it is, you don't win $1 million, or you don't win whatever the big prize is. They are set up to come out ahead if you were the person running it. I am coincidentally right when we're done here. I think some of you fell into this trap in the last unit, even though I tried to make this perfectly clear. The other tutorial packages Each tutorial was 10 pages long. There was lots of questions, and then even at the end it said, check your understanding. There was a bunch of questions in there that you could do. For combinatorics and this unit, you have to go to the textbook or some other source to work on some questions. You're not gonna understand this unit having watched me do 3 or 4 questions. Okay? You got to do some yourself. You really have to do this practice. Okay? The unit assignment for this might be a little longer than combinatorics, but you got to do some along the way if you want to do well. If you want to just scrape through and get 50, maybe that's something different. But can you have a look at that and work on some questions, please?